This is on mathheals.com, where you can find more links to math YouTube videos and computer science. Let's take a look at functions and their graphs. Now we've looked at how to find it graphically, so let's take a look at algebraically. Domain of a function. By default, it's all real numbers except ones that cause a zero in a denominator, or cause a denominator equal to zero, I should say. Cause a denominator to equal 0. Now we'll add on to this. At the end of this course, we'll add a second one on here. In college algebra, you add a third one. The second one deals with radicals with even indexes, and the third one, actually, there's the third one's logs. So it's just like, well, why did you number that as number 1 if there's only 1? So our first one here, we got f of x is equal to negative 2x minus 5. And the instructions say find the domain of each function. Well, by default, it's all real numbers except for ones that cause a denominator equal to 0. Now, to have a denominator means you have to have a fraction. Well, if we don't have a fraction, then by default, our domain is all real numbers. And we'll write it as negative infinity to positive infinity with parentheses around like that. That's interval notation, very short way to write all real numbers. Let's take a look at one that has a fraction. If it doesn't have a fraction, it's very easy. H of x is equal to x minus 7 over 3x minus 1. If you have a fraction, and you find the domain, what we're going to do is we're going to set the denominator equal to 0 and solve. So we'll set denominator equal to 0 and solve. So we'll take the 3x minus 1, set it equal to 0. This is a linear equation, so I'll take negative 1 over, becomes a positive 1. Divide both sides by 3. Those 3's would cancel. And then we got x is equal to 1/3. Now this is the value that causes us problems. If I put 1/3 in here, we got 3 times 1/3, which is 1. 1 minus 1 gives you 0. You can't have a 0 in the denominator. So our second step is to put a slash through the equals. So x cannot equal to 1/3. It can be every other number, but it can't be 1/3. Now, if you prefer to write an interval notation, how you'd write that? This is negative infinity to 1/3 union. That's what that u represents. 1/3 to positive infinity with parentheses on everything. So that's how you write the same thing in interval notation. Personally, I'm happy with this this form right here. Now, next problem wants us to graph a function. And they're just trying to point out here that it's kind of the same as before. So we got h of x is equal to absolute value of x minus 2. You'll get used to function notation be interchangeable with your y. So this is just y is equal to absolute value of x minus 2. So let's graph this. Press clear there, or well, press y equals, press clear. To get the absolute value, that's under your math button. So press math, right arrow to num. ABS is already selected, so press enter on it. And then we'll put in x minus 2. So press my x key, minus 2, and I'll put a closing parentheses, and then graph. And that would be our answer. Now, domain, let me write all these down again. Domain, we saw algebraically, just for graphically, it's the x values where the graph exists. And range is the y values where the graph exists. Our x-intercept is where it touches or crosses the x-axis. And our y-intercept is where it touches or crosses the y-axis. Now there's actually another one that I'll go ahead and write up here. I don't think it's till the next lesson, but it's a 0. And this is where it touches or crosses the x-axis. Now usually this is written in the form of x is equal to a number. You don't write it in point form like you do the x-intercept. Let me grab a drink here. Oh no, it is a section of zeros. Well, we looked at how to algebraically find a domain. And so now we're given a graph and it's asking us to find the different pieces. So number 4. For each graph of a function, find the domain and the range. Now our domain is the x values where the graph exists. Well, if I come up here to the -2, can I go up or down and find my graph? Yeah, I can go up and find it. Here, this is -4, it's cut off, but if I go up to -4, I can go up and find my graph. Now this keeps going forever, this graph does, so if I come out here to x equals -10, I can go up and find my graph. Train is ear splitting next. So like I got it right next door. If I come up here to x equals 10, if I go down I can find my graph. So this actually encompasses all my x values, which would be -infinity to +infinity. Now our range is our y values. And really the only way you can find range is by looking at the graph. There is no algebraic way like we did with the domain. If I come up to y is equal to 1, the question is, can you go left or right and find your graph? Well, yeah, I can go right and find my graph. So it exists at 1. If I come up to y is equal to 4, can I go left or right and find my graph? Yeah, I go left and I find my graph. If I come up to y is equal to 20, clear up here. Well, if I go far enough to the left, I will find my graph, because this keeps going like that. So it's slowly going up, so it'll eventually encompass all my y values going up. And this is going down, so it'll eventually encompass all my y values going down. So our range is -infinity, +infinity. B, the intercepts. Well, our x-intercept, that's where it touches or crosses the x-axis, which is at 4, 0. Sometimes people will just write 4. I'm happy with that. Now our y-intercept is where it touches across the y-axis, which is at 0, 2. Or if you want to just write 2, I'm fine with that too. Now C is the zeros. Well, 0 is just where it crosses or touches the x-axis, which is at 4, and you write your answer as x equals 4. So those would all be our answers for that problem. Let me start a new page here. Same instructions. For each graph, find domain and range. So let's start with the domain. Domain is your x values where your graph exists. Well, if I come out here, I know this is kind of small. If I come out here to -4, if I go down, I don't see my graph right here, but this is going off, so the implication is it keeps going forever. So as it keeps going forever, see how it's slowly going to the left? Which means it'll keep slowly going to the left until it goes to -infinity. This, as it's going down, is slowly going to the right, so it'll go to +infinity. So our domain is -infinity to +infinity. Now our range is our y values where a graph exists. Well, it's going down forever, so it's obviously going to -infinity. This is the high point of my graph, so that's the highest part of my graph. Well, if I go over, that's at y is equal to 9. So it goes up to 9 and then stops. And bracket on 9. The intercepts. The x-intercept is where it touches or crosses the x-axis, which is -2, 0, and 4, 0. Now y-intercept is where it touches or crosses the y-axis, which is up here, which is 0, 8. And our zeros is where it touches or crosses the x-axis, which is -2 and 4. So we'll have x equals -2 and x is equal to 4. Let's look at number 6. Same instructions. It says for each graph, find the domain and the range. Domain is your x values where your graph exists. Well, this is, as it's going down, it's slowly going to the left, so it's eventually going to keep going to the left, which means this goes to -infinity. Now this dot right here means our graph ends there. So if I come to x equals 5, if I go up or down, I don't find my graph anywhere. Actually, the rightmost x value where my graph exists is 4. So it goes to 4 and then stops. Now our range is our y values. Well, it goes down forever, which then means it encompasses all the y values going down, which means -infinity. Now our highest point where the graph exists is right here, and y value wise, that's 7. So it goes from -infinity to 7. X-intercepts where it touches or crosses the x-axis, which is -2, 0 and 4, 0. So -2, 0 and 4, 0. Our y-intercept is where it touches or crosses the y-axis, which is 0, 7. Our zeros is where it touches or crosses the x-axis, which is -2, 4. And again, we write this as, that's weird. Is that the same as the last problem? -2, 0. Sure enough. I'm not very imaginative there, am I? Which would be those. It's not always -2 and 4, if you're wondering. Now, number 7 introduces a new idea. So let's talk about it. If you got f of some kind of number equal some other number, like that. Number inside the parentheses, this is going to be your x. And the number on the other side will be your y. That's what a lot of these problems revolve around, is this idea right here. So again, whatever's inside your parentheses is your x, and whatever's on the other side is your y. Now A here says we want to find f of negative 6, given the graph. Remember what I said. Whatever number's inside your parentheses is your x. So basically we're saying x is equal to negative 6. And this is your y. So we're wondering what y is. So we're going to go to the point on our graph where we got x equals negative 6. Well, let me make this a little bit bigger so you can see it. Well, here's negative 6 on my x-axis. If I go up, then this is the point where my graph is equal to negative 6 on my x values. Well, if I look at my y value, it says 4. So our answer is 4. So basically, we're just looking for the point on our graph where x is equal to negative 6 and then writing down our y part. Now B says find f of 5. Again, what's inside the parentheses is your x, so they're telling us x is 5, and they're wondering what y is equal to. So we're looking for a point on our graph where the x part is equal to 5. Well, here's x equals 5. If I come down to here, here's my point. This is 5, negative 5, so our y part is negative 5. C says find f of 10. Again, this is going to be our x part. So we got x is equal to 10. And we're wondering what y is equal to. Now if I come over here to x equals 10, if I come up to here, here's our point. Our y part is 5. I'll grab a drink here. Okay. D says, is f of negative 3 positive or negative? Well, let's just find out what f of negative 3 is, and then we can go from there. Again, what's inside parentheses are x, so they're telling us x is negative 3, and we're wondering what y is. So let's go back and look at our graph, where x is equal to negative 3. Well, here's negative 3. If I go down, here's where my point is. My y part is negative 6. Well, negative 6 is obviously negative. E. It says, for what numbers x is f of x equal to 0? So what they're telling us here is they're telling us the y part. They're telling us y is 0, and they're wondering what x is equal to. Well, let's go to where y is equal to 0 at. Here's y is equal to 1. Here's y is equal to negative 1. Y is equal to 0 is right here, which is actually the x-axis. If I come over to here, this point right here has y is equal to 0, and the x part is 6.8. But if I come over to here, this part also has y is equal to 0, and the x part is negative 5. So those would be our two answers for that part. Part E, so let's look at F. F is, what is the domain? Yeah. So the domain. Remember, domain is your x values where your graph exists. Well, this right here is our leftmost point. And if I come straight down, then our x value is negative 7. You can also get it off the point. So the negative 7 is the leftmost where it exists. Now here's the rightmost part of our graph where it exists. If I come down, it's 10, or I could get it off the point there. So it'd be negative 7 to 10 is our domain. And we put brackets on those. Now our range is our y values where a graph exists. Well, this right here is our lowest part of our graph. So if I come over here, it's negative 6. Because again, you're looking where your graph exists. Now this is the highest part of our graph, and if I come over here, it looks like it's 10. So our range is -6 to 10. H looks like, what are the x-intercepts? X-intercepts is where it touches or crosses the x-axis, which is -5, 0, and 6.80. And y was our y-intercepts, and that's where it touches or crosses the y-axis, which is right here, which is 0, -3. J is for what numbers f of x is equal to -6. Okay, so they're telling us here that y is equal to -6, and they're wondering what the x value is. Well, here's -6. If I come up to here, here's my point. Wait a minute. Y is equal to -6, sorry. So here's y is equal to -6. So I come over here, this is where our y is -6, our x part is -3. So x is -3. Now k, I think, was f of 10. Or no, f of x is equal to 10. So f of x equal 10. So here they're telling us the y part. They're telling us y is 10, and they're wanting what x is. Well, if I come up here to y is equal to 10. If I come over here, this is my point. And going down, as close as I can tell, it looks like 9. So x is equal to 9. And L, I think it was zeros. Zeros where it touches or crosses the x-axis. Well, touches over here at -5, or crosses, I should say. So -5. And it also does it over here at 6.8. Now remember, we write these in the form of x equals a number. So those would be our two answers. And the end of that section.